What's up guys, I'm Maths here, and today we're looking at circles. Now, we are going to be looking at more complicated questions. It's a higher paper, so we want to try and prepare ourselves for, I don't know, the worst case scenario maybe. There's nothing too complicated here. I mean, there's some circle questions that involve volume, obviously, for cylinders and things like that, and further trigonometry. We're not going to touch on that. We're just going to focus on the area of circle, which is pi r squared, and the circumference, which is pi d, or 2 pi r. So this first question from AQA asks us to work out the shaded area, and we've done this quite a few times before where we're working out a shaded area, and instead of working out the shaded area, we work out the total area and then take away the bits we don't want. First thing to notice this question is it says that the two quarter circles are identical, which means the first thing we can do on this diagram is understand that the distance here is going to be 6 centimeters, and the distance here is also going to be 6 centimeters, so we can just halve it. Now, why is that important? Well, if I drew in the full circle here, then you'll notice that 6 centimeters is the radius of that circle, so the radius is 6 centimeters. So if the radius is 6 centimeters, we can also identify another side, which is here, is also going to be 6 centimeters, because the radius of a circle is always the same. So what looked like not enough information to answer the question, I mean, there's only one measurement, we can then find out all the other measurements. It's quite a clever question. Next thing to realize is we have 2 quarter circles, but we're not going to identify them as 2 quarter circles. Now I'm just going to show a bit of magic here, hopefully, if this works. So if I draw in these two badly, because I don't want to spend ages on this, and if I move them across here, what we're going to do is just put these 2 quarters together to make a whole, like a semicircle, like half a circle. So we're just going to interpret this as half a circle from now on, okay? Simple as that. Okay, let's go through the steps. So we're going to first of all work out the total area, the area of the rectangle. So I'm going to just show the examiner, that's what we're after. So rectangle, I'm just going to say, look, we're talking about the rectangle here, and we'll do the area, which will be 12 times 6, which is 72. Simple as that. Then we'll work out the area of the semicircle. Remember, we're viewing it as a semicircle, not 2 quarter circles. So the area is just going to be pi times r squared, and then it's half a circle, so we then need to times it by half. So it'd be pi times 6 squared, which is 36, times a half, and 36, half of 36 is 18, so it's just 18 pi. I'm just going to leave it in terms of pi. Okay, so we want to work out the shaded area. So we're going to do, so area equals, we're going to do the 72, and we're going to take away the 18 pi. Right, this is the bit where I get my calculator. So 72 take away 18 pi is 15.451 blah blah blah, which I'm going to round to 15.45. And I'm just going to show the examiner that I've used 2 decimal places. Could have used 3 significant figures. That's also absolutely fine. And I would just write 3SF if I did that. So what looked like not enough information for this question ends up being absolutely fine. Not a difficult question when you understand that the radius of those quarter circles is 6. Okay, next we move on to Edexcel's offering, and I like this question. It looks really complicated, especially on an uncalculated paper, which is on paper 1, so you don't have a calculator for this, but it's all about understanding how to use things in terms of pi. There probably are quicker ways of doing this. I'm not going to do those ways. I'm going to do the way that it's kind of the easiest to explain. So we've got 3 circles that we need to deal with, and I know that B and C are not circles. They're kind of like the circumference of circles, the thick circumferences of circles, but I'm going to call them circles. Okay. So we want to work out the area of A, which actually is the easiest because the area is just pi times r squared, so pi times 4 squared should be, what, 16 pi? That's the easy bit. Right, now we're going to work out the area of B. So the area will be pi times, now it's going to be 4 and 3, okay, so that would be 7, so times 7 squared will be the area here of the whole thing, but I don't want the whole thing, I just want the ring, the B ring, so I'm going to take away the 16 pi, okay, take away this bit here, so I leave the shaded bit, okay, so that's 49 pi, take away 16 pi. Now the way you deal with pi is similar, it's not the same, but it's similar to the way you deal with algebra. So if it was 49x take away 16x, you know, you just take away the numbers and then you're left with that amount of pi, okay? So we do 49 take away 16, which is 33 pi. So B, the shaded area, is 33 pi. Next we move on to C. So the area will be pi times, and this time it's going to be 4 plus 3 plus 3. So that is 10. So why I keep doing that? So that would be 10 squared, and then we've got to take away the 33 pi. We've got to take away the whole of, oh, not the 33 pi. No. Got to take away the whole thing. So it would be the 49 pi. Nearly made a mistake there. So we need to take away the whole thing, not just the shaded bit. Okay, so that's 100 pi. Take away 49 pi. If I just move down a bit, which would be 51 pi. So we're asked to work out the fraction that's shaded. Okay. And actually, looking at it, we don't need this bit here. We don't need C at all. All we need is the total. So I'm going to get rid of that C, and I'm just going to say just the total. Okay. So I'm not interested in working out what C is. What that shows now is just the whole thing. Okay. Because when you're working out a fraction of something, it's always the bit you're interested in over the whole thing. So it's over that 100 pi. Okay, so we now need to work out fraction. So the fraction shaded. Right, so the fraction, so shaded, equals, so it will be the bit that's shaded, the bit we're interested in, which is 33 pi, over the total amount, which is 100 pi. Now, something interesting with fractions, as you know, is you can divide top and bottom by the same thing. So we can divide top and bottom here by pi, and it just leaves 33 over 100. Now, 33 over 100 is not a third, okay? If we convert it into, I don't know, a decimal, that would be 0.33, okay? We know a third is 0.3 recurring. So, is it Daisy? Yeah, Daisy is wrong. It's not exactly a third. It's almost a third. It's very close to a third, but it's not exactly a third. Now, you get sick of me saying these in these videos, but you must answer the question. This is not enough to get full marks. And how many marks is this? 4 marks. So you might get 3 or 2, but I haven't got the 4 out of 4 because I have to say no. And you could say, yeah, Daisy is wrong because 1/3 equals 0.3 recurring, or something like that. Words to that effect. Okay, so you have to, the important part of this that you must write down, because I see so many students lose marks over it, is this word here. Either yes or no, just make sure you answer the actual question, as well as obviously showing all your working out. Alright, so we've had 2 questions on area. It's only fair that we look at circumference and perimeter. So this OCR question asks us to find the perimeter of the shaded part. So the perimeter of the shaded part will be this one, and these ones. So that's the total perimeter there. So we're going to break it down and do it step by step. So I'm going to do probably this one first. So I'm just going to label it as A, just to be, I don't know, show you what I'm doing where. So we know that circumference, which I'm just going to use C from now on, equals 2 pi r, or pi d, but here we don't have a diameter. So it's 2 times pi times the radius, which on A is going to be, where is it? 6 centimeters, so times 6. But we're not looking for circumference, okay? So I'm actually just going to delete all of that because we're not looking for that, okay? We're looking for arc length, and arc length is different, not much different. Arc length. Okay, so we've got to do just something slightly more. Oh, don't want that bit. I'm just going to drag these out because we haven't got a full circle here. All we have is 45 degrees of a full circle. So if we did 2 pi r, we'd get the circumference, or the circumference of the full circle. So we just need to find out what fraction we've got. So it says 45 there, and we know all circles go up to 360. So we just need to times it by 45 over 360 because we don't have a full circle. Okay, so I get my calculator out. Probably do that, most of that in my head, but I'm not going to. So 45 over 360 times 2 times pi times 6, and that gives me 3 over 2 pi, which I'm just going to leave that for now, which would be what, 1.5 pi. Okay, next we're going to work out B. Now B we're not given the radius for, so we're not given what this is, but we can work it out because it's going to be 6, which is the full radius of arc A. Take away this 3.5 here, which would be 2.5 centimeters. Okay, so again, arc length. And it's the same angle, so 45 over 360 times 2 times pi times this time 2.5. Okay, so get my calculator again. So 45 over 360 times 2 times pi times 2.5. And that gives me 5/8 pi. Now you might ask, why am I leaving these in terms of pi? Well, I know that I'm going to do calculation with them later. So if I wrote out the decimal, I'd have to round it round it at this point, and then my answer might be off because I've rounded it earlier, if that makes sense. If you are going to write down the decimal, then try and do it to 4 decimal places in your working out so that you don't get any rounding errors. Right, so we've got A and B. We are given the other two because that's actually labelled, and so if that's 3.5, this will be 3.5 here. So we can just add those on. So time to finish. So the perimeter is going to be A, which is 3 over 2 pi, plus B, which is 5/8 pi, and then plus 3.5 plus 3.5. So I'm just going to type that into the calculator. So plus that plus 3.5 plus 3.5, and it gives me the answer of 13.6758 blah 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 blah. And this is the time now where I can round it, and I'm going to round it to 2 decimal places. if you've got a choice of how to round it, always do 2 decimal places or 3 significant figures. And generally speaking, that's going to be a good way of rounding. However, always check the question, because it does actually tell you 3 significant figures. So that's not going to be adequate. If it tells you what to do, if it tells you it wants something, you must oblige. So 3 significant figures will be 13.7. I'm just going to say that that's the 3 significant figures. So 13.7 is my answer. Well, I hope you enjoyed this video. If you did, please click like, it really helps out. If you want to see more from us, we are releasing videos Monday, Tuesday, Wednesday, Thursday and Friday, every weekday. So click subscribe, make sure you're up to date. If you want to see more from us, as well, even further more than us, from us, go to our website, onmaths.com. Loads of free resources. You can even sign up to save your scores, all completely for free. There will be a link appear magically above the video now. Otherwise, I'll see you tomorrow.